minus mu naught epsilon naught dE by dt equals to, okay, I say only free current, but that's not entirely true. The current, we just, the charges in this volume could be charges, that are free, and also at the same time charges that spin about some axis, about their own axis, or charges that orbit about the charge. So let's in general assume all kind of currents. That is a result of actual movement of charge. So in that case, this is the equation where we need to start. Mu naught epsilon naught dE by dt equals to mu naught J. That's where we started when we determined Maxwell's equation in math, right? So J at this stage it can be free current plus bound current plus polarization current. So if I solve for J here, what would I get? I get J equals to curl of B over mu naught minus epsilon naught E by dt. Okay, so if I substitute this one in here, what would I get? dW by dt equals to the integral over the volume, the electric field, dotted. Okay, before I substitute, just let's find a simple relation for E dotted K. So E dotted K equals to then E dotted with curl of B over mu naught minus of epsilon naught E dotted dE by dt. All right. Now, just let's apply one vector identity that says the divergence of E cross B is equals to B dotted with the curl of E minus E dotted with the curl of B. Just the product or make that cross product. So then I can write E dotted curl of B, E dotted curl of B as E dotted curl of B as B dotted with curl of E minus the divergence of E cross B. So in terms of that, then I can express E dot J as
Can we assume that the curl of E is still 0?
no, the curl of E is not 0 anymore.
Oh, okay.
Remember Faraday's law?
Oh,
So yeah, so if in fact let's apply Faraday's law at this stage. So if you apply Faraday's law, from Faraday's law, we know that curl of E equals to minus dB by dt. So if I apply that in here, I would have E dotted with the curl of B is equals to B B dotted with the minus sign, so that becomes minus dB by dt minus curl of not curl, divergence of E cross B. So now just place this one in here, then you would find E dot J becomes E in place of that. If I divide this by mu naught, so that's going to be mu naught. This is going to be mu naught. So I can replace these in place of that. Then I would find minus 1 over mu naught into B dot dV by dt. So now if I write this one first, because these two are related and they are going to lead to very important result that we saw last semester. So minus, so if I wrote this one first, that's going to be epsilon naught into E dot dE by dt, and this time minus the divergence of E cross with B over mu naught. All right, just give me 5 minutes to arrive to the important relation, important conservation law in electromagnetic field theory. Okay, so what's gonna be E dot B by dt? That's gonna be just twice of B dot dB by dt. Agree? Just if you apply the product law. All right? So this would be B dot dB by dt, then it's going to be half of d by dt of B dot B, that's going to be B squared, right? Are you following me? So similarly, for the electric field, d by dt of E dot E, you get half of d by dt of E squared. So then we can see that this one E dot J, then you can write it as 1 over mu naught with the minus sign of half of B squared, well, d by dt of B squared minus 1 over 2 or epsilon naught 1 over 2 d by dt of E squared. All right, and this term minus the divergence of E cross H. All right. Now let's plug in this in our expression for total work done per unit time here, and do the integration over the volume. So that, if I do that, if I integrate this over d tau over the volume equals to minus 1 over mu naught. So this is the whole thing integrated over the volume. So this one d tau, and this also integrated over the volume d tau. Now I can pull the time derivative outside of the integral, right? There ain't going to be any change.